Alrighty then. This is for all the CAT classes. I'm sure you got the message about e-learning days. And the CAT team, us three CAT teachers, all got together and decided we're going to do some short little things on 5.3 and 5.4. And hopefully, whenever we meet again, you'll be ready to kind of review that in one day. Um, and then we can proceed on with future stuff. So hopefully you do your parts, watch these videos. We tried to keep it short, and we definitely simplified the homework, made it a little bit shorter just to get the essentials done. So here we go. All right, 5.3 actually just deals with these two identities, but then we do have another set called the co-function identities. Let me take a pause for a second, get my ducks in. All right, then maybe one question you might have is, will I have to have these memorized? And in the past, what we thought was definitely have 5.1 memorized. Those identities that, at least in my class, we've already had an identity quiz. I'm sure the other ones as well, just fill in the blank. But through doing your homework, we might have a matching section that you do correlate these identities with the correct, this side over here. This would be what, you'd have to fill in here. And the way I always thought of cosine, look at it. Cosine of a sum of two different angle measures equals cosine, and then look at the sign, opposite, and then sine. And I'll show you how this breaks down as far as, how it's used and so on and so forth. Just be aware that after doing your homework, you should be able to see some subtle differences between this one and tomorrow's notes, which is the sine of sum of two angles and sine of difference of two angles. And then we'll see where we go from there. But the usage of it. Okay, so just pretend you're maybe going to be an engineer. And in engineering, we want exact answers. Otherwise, doors won't fit when we make cars, or so on and so on and so forth. I've talked about that in my class of why do we need exact answers, and there are indications and when we need that, and let's just hopefully take it from there. So we already recognize that negative 15 degrees is not one of our 30, 45, or 60s from chapter 2 and chapter 3. And that's the point of this. I could, by using this identity, get two angles that are either added or subtracted that are one of those or both of those angles that we're talking about there. So what two angles maybe in this case subtract to be 15 degrees? That's from our exact angle or nice little triangles that we have. And the answer is 60 and 45. And I'm going to use the difference rule. I'm going to make that really obvious. So that means I'm using this rule to break this down. And then what I'll be able to get is an exact answer out of this. All right. So hopefully you understand the idea of why these identities are used, so on and so on and so forth. And I'm going to continue on with this. So how does this break down? Formula usage says 60 goes here, 45 goes here, plus cosine, the signs are different, helping you on that memorization. And then sine of 60, sine of 45. That's why I like this chapter too. It goes back to you hammering down what's the cosine of 60, what's the cosine of 45, and sine, and so on and so forth. And what I'm going to do is draw real two quick triangles. I know you could use your unit circle, and you should have this memorized. But my class, we always go back to the triangle. Side opposite 60 is root 3, side opposite 30 is 1. Hypotenuse is 2, or in other classes, the unit circle, this is 1, so divided by 2, divided by 2, divided by 2. Some people do the little hand thing in order to figure out, hey, whatever you need to do to know what the cosine of 60 is, and then that's what you replace. Do not put the word cosine here. The evaluation of cosine of 60 degrees is the fraction. All right, so we get that all the time with students. the word cosine's gone. You evaluate the cosine of 60 and get the fraction 1/2. And then for 45, I'll go ahead and do that unit circle idea. Okay, fine. My class, it's 1 root 2. But then you want to divide everything by root 2 to get that to be a unit circle value. You should know that the cosine of 45 is root 2 over 2, and also the sine of 45 is root 2 over 2. All right, and then what's the sine of 60? That's back to this triangle. Sine is opposite over hypotenuse, which is root 3 over 2. So I kind of got my triangle in the way here. So hold on a second. Yeehaw. All right. Oh, it didn't work. Yeehaw. Nice. All right. So we get that. Nope, not so nice. There we go with the computer mistakes. All right. Now the video is going to be a little bit longer with my little imperfections. All right. Root 2 over 4 plus root, not 5. 3 times 2 is 6 over 4. Can I add these two together as like terms and make that root 8? No, you can't. That's like x and that's like y. So the final answer is root 2 plus root 6 all over 4 if you wanted to put it over a common denominator. All right, now what we have is an exact answer for this that we couldn't do before. So we need to see that work. We need to see these plugged in. Blah, 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 blah. Work shown. Oh, no. Now we got radians. Yeah, and I think I'm going to go ahead and do subtraction in this one again, or the addition of two negative angle measures. But we'll go ahead and do subtraction. And this is going to be a common theme here, with 12 being a denominator in radians when we do these sum and difference. But that's okay. So how we have to think of radians is I have to have a sum or difference of two angle measures that end up being a 45, a 30, or a 60. And over 12 is a nice little denominator because I can do a whole bunch of different things, like 4 pi over 12 minus 3. Wrong, Mr. Samulus. You got to reverse those. That's 3 pi over 12 minus 4 pi over 12. This is one option. All I got to know is a little bit about fractions to understand that that actually equals negative pi over 12. Can we have another one? No, I guess that would be about it. I was thinking about 6 pi over 12 minus 4 pi over 12 would be 2 pi over 12, which does not, or reverse it. And that would not end up equaling that. So I guess we're kind of limited on this one. This is equal to cosine of the difference of these two angles. So I'm going to go ahead and use the difference identity. Why these two? Because they reduce to be pi over 4. That's a 45 in quadrant 1. And then this one's pi over 3, which is the 60 in quadrant 1. And now I have those two angle measures where I can evaluate cosine exactly, and sine. Because now it's time to use the formula which says, okay, difference, it's cosine, cosine. Now if you're getting the formula usage, this is the point of this. This is why we can use this identity to evaluate exactly, getting an exact answer. Cosine, opposites, and then it's sine, sine, everywhere, sine. All right. And then, hopefully you're from the last example, and eventually, yeah, we don't want you to be writing triangles anymore. We want you to be able to come up with these without having to write anything. We want you to know that 45 degrees is pi over 4, and the cosine of 45 is root 2 over 2. Refer to the last example, how I actually got that. All right, I'm going to speed this up. Cosine of 60, we just had that. So this is very much the same kind of question. Actually, I think it is the same. Cosine of 60, oh, sorry, that's a half. Wrong, Mr. Samulus, wrong. Half, and then plus sine of pi over 4, sine of 45. So this is exactly the same as the other question. I'll tell you why in a moment. Sine of pi over 3 is root 3 over 2. Hopefully I didn't make any mistakes there. Sine of a 60 is root 3 over 2. And then this is the same thing. So it's root 2 plus root 6 over 4. And then I'm kind of a buffoon. But I'm not. I did do these on purpose. The angle measure, negative 15 degrees. If I converted that to radians, take a wild guess what you would get. Negative pi over 12. So I did the same exact question on accident, but not really. I just wanted you to work with radians and see how they work. That's why the answer ended up being the exact same. Okay, and then we have these, which is what I call reverse analysis questions. And notice what it says for the directions. Use identities to find each exact value. Do not use a calculator. Well, these two are pretty specific. But then we got this one. This is strange. But wait, when I look at it, this actually emulates this formula that I saw on the right side of the identity. Call it a formula. An identity kind of works like a formula because it's true, and then I work with it like I work with formulas, kind of idea. So with that being the case, then I think what they want me to do is turn this into the left side of the identity, which this one is the sum formula for cosine. And then in tomorrow's notes, we do sines identity and also tangents. So we'll put it all together. Hopefully this first day works out all right for you. So that's what this is. I'm going to take cosine of, and see what 7 pi over 9 plus 2 pi over 9 ends up being. Do I have that right? Okay. What am I doing? All right. And then, again, I wanted to look up here. So subtraction. So we had a subtraction sign, so it's plus of those two angle measures. All right. 7. Oh, okay, right. I was getting nervous for a second there. I couldn't add correctly. So how does this evaluate then? Well, actually, what this ends up being is cosine of 9 pi over 9, which is cosine of pi. And then I don't know how you do this in your class. My class, I always make them go like this. Pi is here, and this is coordinate trig. So it's this coordinate that you're selecting from to evaluate this exactly. All right, so it goes back to circ or ticks. It goes back to chapter 2 and chapter 3. Really, chapter 3, because that's where we had radians. And the cosine of this value is actually negative 1 over 1. So when we use the difference rule, this comes down to an angle that we had in chapter 3, and we evaluated that. So just make sure you understand that's what's going on there. So that's the answer. All right, this one we were able to reduce it down to a chapter 3 angle measure and then evaluate from there. All right, so that's the end of that little section. I kept it simple. We wanted to keep it simple. The usage of this sum and difference for cosine. Wait for tomorrow's notes when we do sines as well. And then hopefully it all comes together what these identities do. Because then in this day, I hate to do it, but there is one more set of identities that they share with you in this section. And it's the cofunction identities, the 90 minus identities, I like to call them. And what's the same as 90 degrees in radians? And the answer to that is pi over 2. So this is also a form of that identity, just putting it in terms of radians, because I probably will use that, and it is used. Oh, and it says so right here, boom shakalaka. All right, so just by reading, you could see that we could replace that with pi over 2. And then please read your directions, because the first question almost looks exactly like the first question that I did up there. But this one says, write this value in terms of its cofunction of a complementary angle. And that's what you should understand. We've actually had this identity before and used it. We've actually tested you on this identity or these identities in a previous chapter. I think it was 3 or 2. I can't remember which one. All right, so sine of 15 degrees. Read. So if they want me to use the cofunction complementary identity thing, they want us to use this one. So this should equal cosine of 90 minus 15, which is cosine of 75. And then that's the answer, and I can't evaluate that. They're just writing it in another function. So we're writing it in terms of cosine. Oh boy, radians. So this should equal cosine, but since it's in radians, you want to use the pi over 2 minus. And then we all love radians because we all love fractions. So what we need to do is get a common denominator. So I'd have to multiply this by 5. I'd have to multiply this by 2. I love fractions. And then this would be the cosine of 5 pi minus 4 pi, which is pi over the common denominator 10. Okay? So just read the directions and understand that this is a completely different section of what we got going on here. And then use identities to fill in each blank with the appropriate trig function name. This is a trick. This is the co-function identities, not the sum or difference. So they do have some matching sections using the sum and difference, but I mean this one is pretty easy. You look at this and you look up here. Which one has cotan? Oh, cotan goes with tan. So this must be tan in this blank. All right, and then that matches. So this is not a sum or difference. This is actually a co-function. Who does sine go with? Sine goes with cosine, but I question myself. Is that right? Let me check that. Let me check that real quick. Wrong. So what should be true is pi over 2 since it's radians minus 2 pi over 3. And then we got the old common denominator times 2 times 3. 2 times 2 is 4. 3 pi minus 4 pi is negative 1 pi over 6. Check, baby, 1, 2, 3. It works out, okay? Hopefully that's good enough. Shortened assignment. Keep up with the stuff.